This is review for Chapter 3. This is Part 1 of Part 2. So in Chapter 3, we started by talking about functions. And a function has to mean that there's only one output for every one input. So you can't have two y's for the same x. Then there's also a linear function, and a linear function is a function whose graph is a non-vertical straight line. So it has to be a straight line, and it has to pass the vertical line test. So it is a function, and a function means it passes the vertical line test. So a few examples. This one is a function because if I draw vertical lines here, it will only cross each point once on the graph. Same with this one. And same with this one. This one has a positive slope, this one has a negative slope, and this one has a slope of 0. It is still a linear function with a slope of 0 because it passes the vertical line test. This last one, however, is not a linear function because it is a vertical line. Its slope is undefined, and if I draw a vertical line, all the points are the vertical line, so it does not cross just once. If you are looking at an equation of linear functions, you have to make sure that it has a regular looking x, meaning an equation of a linear function must have an x to the power of 1. So it has to look just like this guy, regular little x. And it can be written in the form y equals mx plus b. If you can get y all by itself, and you still have a regular x to the power of 1, it is a linear function. So if I have x plus y equals 2, solving for y to put it in this form, I have y equals negative x plus 2. This is a linear function because it has a regular x. If I have x squared plus y equals 2, I have an x squared, and the squared means it is nonlinear. If I had x plus 1 times x minus 2, I have 2 x's. That is also nonlinear. Next, we were talking about different kinds of domains. So we have a discrete domain, and that is a domain meaning that x values are only certain points. It is not a solid line. So we have a graph with just some dots on it. So dots and discrete, like this. The other kind is a continuous domain, and that means that the domain is all numbers in an interval, so it is a solid line. So this is a solid line. It is continuous. It is not a linear function, though, because it is curved, but this is continuous. If we have equations or graphs and we are asked to find the intercepts, the x-intercept is the x value where the graph crosses the x-axis, written as whatever number x is, so your x equals that number, comma, 0. This means the y value is 0. So if I were to find the x-intercept of y equals 1/2 x plus 3, I'm going to make y 0 and keep the x and then solve for x. I only have one variable at this point, so I'm going to solve for that. So I subtract 3, and then to divide by this fraction of 1/2, you multiply by the reciprocal, so you flip it and multiply. Then I get x equals negative 6. That is the x-intercept. And on my graph, it would be this point where it crosses the x-axis way out here. My y value is 0. I don't go up any to graph it. It's just on the x-axis. Then to find the y-intercept, it is the y value of the graph that crosses the y-axis. 0, whatever number you get equals y. So to find it on the same equation, y equals 1/2 x plus 3, I'm going to keep the y, and my other variable, x, is 0. Now I have one variable, and I will solve for y. 1/2 times 0 is 0, then I have a plus 3, so y equals 3. And then this is my y-intercept. On my graph, that would be up here where it crosses the y-axis. I didn't have to put in a 0 when it's y equals in this form, because y equals mx plus b, this b value is the y-intercept. And we just saw that, because this middle part, 1/2 x, becomes 0. So that's how you find x and y-intercept. To find the slope, that's the m value. Whatever is in front of x is the slope. If there is no number in front of x, slope is 1. Now let's find the slope x and y-intercepts of y equals 4x plus 7. My slope, I can see here, is 4. Then to find my intercepts, ignore this blue part for a second. Just set it up, and you have your parentheses, comma 0, parentheses, 0, comma. So just set it up with the orange here. And you can see in y equals mx plus b, this 7 is my y-intercept. I don't have to do any other kind of algebra to find that. It's just given in the equation. But my x-intercept is not. So my x-intercept, y becomes 0. So instead of writing y, you write 0 equals 4x plus 7. Then solve for x. Subtract 7, divide by 4, and x equals negative 7 over 4. You can put the negative out in front or on top. If you put it on top, it makes it a little easier when you go to graph.